Now that you've mastered writing the formulas from seeing the name, we're actually going to learn about nomenclature and what that means. So nomenclature actually means name. It's a naming system, and that's what it means, and it's the language of chemists. So we're going to talk about how to do that first for just ionic compounds. There are a few rules that you need to follow, and that will set you up to be able to do covalent in the next section of our module. So first, let's just go over some facts about ionic compounds that we've already been over so that you can just review and have this in your head for when we talk about naming. So the first thing and the most important thing is ionic compounds are between a metal and a nonmetal. Flat out, no exceptions, only metals and a nonmetal. It's never going to be anything different. Your metal is going to be your cation ion, and your nonmetal is going to be your anion. And so the sum of the charges, when you put these together, they have to add up to 0 because that's the only way you get a stable compound. So there's no charges. You don't see any plus or minus, you just see numbers. And that number comes from the oxidation number, which is how many electrons they gain or how many electrons they lose. So when you see magnesium and fluorine here together, you'll have 2 fluorines and 1 magnesium, because magnesium's charge is 2 and fluorine's is 1, so you do your pop, lock, and drop it, and you get MgF2. And then you use subscripts, which as we know are numbers below this line of script, to represent those numbers. And they're written in the lowest possible ratio. So if you have 4 calciums and 8 fluorines, you're not going to write that. You can divide both by 4, you're going to write CaF2. The next thing we're going to talk about, which we haven't touched on yet, are polyatomic ions. Polyatomic ions are a charged particle composed of multiple atoms. Poly means many, atoms, atomic, that makes sense. And they're held together by covalent bonds. They generally end in ate or ite. That could be something like sulfate, cuprate, I'm running out, nitrate, nitrite, there's both of those. There's things like that. I will give you a list of all the polyatomic ions that you will need. You will not have to memorize them, although that will be recommended. So sulfate is SO4 2-, sulfite is SO3-, so ite has 1 less oxygen, as you can see there, but the charge is still the same. You need to put them in parentheses if there's going to be more than 1. So if you have 2 sulfates coming into this atom, you're going to put parentheses around it and then mark a 2 around that parentheses. For naming ionic compounds, it's a little bit different. So the first thing that you have to do from the name is determine if the compound has a polyatomic ion. That is your first step. Your second step is to name the cation first and the anion second. Your polyatomic ion, 9 times out of 10, it's set for ammonium, is going to be your anion. So that will be coming second. If the anion comes from the periodic table, you just take out the last few letters and replace it with "ide." So chlorine is chloride, fluorine is fluoride, boron is boride. And if you have a polyatomic ion, it keeps its name, you don't change that. You don't turn nitrate into nitride, because nitride is just nitrogen. We're going to see some examples of this after this video, so don't worry about that. You'll also sometimes see a Roman numeral. Roman numerals are charges of metals. You really only need this for your transition metals. So when you name certain metals in the periodic table, you have to put in their charge because they can have multiple ones. So the ones that you don't need, group 1, no Roman numerals, group 2, no Roman numerals, and then Al3+, Zn2+, and Ag+. But all of those, Al can come in a 2+ where you would put the 2 in Roman numerals. One of the most important things, before you write the name or formula of an ionic compound, you should check to see if it has a polyatomic ion or if it has or will need a Roman numeral. So we're going to go through that and see some examples. The first thing that I want you to do, just comprehension-wise though, is answer these questions in your module packet. There's 4 of them, and then we will go on from there.